All right, this is solving absolute value inequalities part 1. I'm going to split it into 2 parts. So solving absolute value inequalities. We have solved absolute value equations, but not inequalities. When I ask you to solve an absolute value inequality, what I'm really asking you to do is write a compound inequality of all of the possible solutions. So your solution to an absolute value inequality will actually be a compound inequality. So let's look at this one. This absolute value of x is less than 3. What are some numbers that could fit in there? Well, the absolute value of 2 is less than 3. The absolute value of 2.5 is less than 3. The absolute value of 1 is less than 3, etc., etc. But we could also have the negatives. The absolute value of negative 2 is less than 3. The absolute value of negative 2.5 is less than 3. The absolute value of negative 1 is less than 3. And we could name a whole bunch more of the little parts, little decimals. But what we're seeing is, like, it could be negative 2.9 and it could be 2.9, but it couldn't actually be the 3 because the absolute value of 3 is not less than 3. But we could do negative 2.99999, so it's everything up to 3, but not including 3, and up to negative 3, but not including. So that compound inequality would be negative 3 is less than x is less than 3. It's all the solutions in between negative 3 and 3. I've decided to change this next problem to be a different number, 10. But it's the same thing. The absolute value of x is less than or equal to 10. Now we can include 10 in our answer because the absolute value of 10 is less than or equal to 10. The absolute value of negative 10 is less than or equal to 10. And we could do 9 and negative 9. We could do 8 and negative 8. But you can see it's all the numbers that are in between 10. So the solution set would be all numbers between negative 10 and 10, but it also includes negative 10 and 10. So our general rule for writing an absolute value inequality is if it is a less than, because we have two different types, if the absolute value inequality has a less than or a less than or equal to, it's going to be an and inequality. So less than or equal to absolute value inequalities will be an and inequality. All right, let's look at this. I have a feeling some of you know where we're headed. Let's name all of the, again, by solving the absolute value inequality, I'm really asking for what compound inequality will show us all the solutions. So let's start naming some that fit this one. The absolute value of 3 is not greater than 3. What about 3.1? The absolute value of 3.1 is greater than 3. The absolute value of negative 3.1 is also greater than 3. So we could have 4. The absolute value of 4 is 4, and that's greater than 3. The absolute value of negative 4 is 4. That's greater than 3 as well. And 5 and 6 and all the parts in between, negative 6, negative 10. So what we're seeing is it has to be at least greater than 3, or it could be less than negative 3. So this is going to look like x has to be less than 3, or x has to be greater than, less than negative 3, greater than 3. So let's try this one, but again, I'm going to use a 10. So the absolute value of x has to be greater than or equal to 10. So I'm going to first find all of my solutions, or many of my solutions. It could be 10 this time, because it's or equal to. It could be a negative 10, because the absolute value of negative 10 does equal 10. This time, instead of going less than, it has to be more than. The absolute value of 11 is greater than or equal to 10. The absolute value of negative 11 is greater than or equal to 10. And 12 and negative 12 and all of the parts in between. So now our inequality is going to be x has to be less than or equal to negative 10, or x has to be greater than or equal to 10. So again, our general rule, what you need to remember is that if the absolute value has a greater than or a greater than or equal to, it is going to be an or compound inequality. You need to somehow write this in your notes that you remember this and possibly refer back to this slide often. So let's do a couple practice problems. Before I begin, I'm going to just make some notes up here to remind myself that if it is a less than or a less than or equal to, it's going to be an and compound inequality. If it's a greater than or a greater than or equal to, it's going to be an or compound inequality. All right, so the first thing you have to do to solve an absolute value inequality is write it as a compound inequality. It is not going to be your final answer most of the time, but it's the start. So before I begin solving this first example, I'm just going to write, I notice that it is a less than, so I know it's going to be an and. So I'm going to think of what that first example looked like. It was the absolute value of x was less than 3, and we wrote the compound inequality, -3 is less than x is less than 3. So what we did was we took whatever was in the absolute value and we put it in between the two inequality symbols. This was 3, so we put it in between 3 and its opposite. This is 5, so we're going to put it in between 5 and its opposite. And then it is just a matter of solving both parts. Solving both parts, or really it's all three parts. You can rewrite it as two separate inequalities with an and in between, but most of you are just showing this. So we know now that -7 is less than x is less than 3. So x has to be between -7 and 3. All right, let's go to the second example. This is a greater than, so I know it is going to be an or inequality. And our easy example, and the reason I go back to this easy example is sometimes if you make things easier with easier numbers, it's easy to see how to get your answer. So the absolute value of x is greater than 3. We wrote it as x is greater than 3 or x is less than -3. So we took whatever was in the absolute value out, in this case x plus 9. It was greater than 3, here it's greater than 5, so we're just going to rewrite that and then write an or, so we're connecting. And then we still had whatever was in the absolute value, but this time we switched the inequality symbol. Oops, let me grab the pen. And we made the number its opposite, so -5. So now I'm going to solve all parts. So x is greater than -4 or x is less than -14. And I highly suggest every time you solve an inequality in an equation, you choose a number, plug it back in to see if it works. So for example, here you might choose 0, and here you might choose -15. Plug it back in, see if it works. All right, two more quick examples for this first part. This will get you through the majority of the assignment, solving and graphing. So the first one, again, I see is a greater than. With a greater than, I know it is going to be an or. So greater than or equal to is going to be an or. And I'm going to write down that easy problem again. The absolute value of x is greater than 3. We had x is greater than 3 or x is less than -3. So I took whatever was in my absolute value, so 2x plus 2, and I just kept the sign the same and the number the same, is greater than 8. Or, I'm actually going to write it over here so I have room to work. We took whatever was in that absolute value, 2x plus 2, and we switched the sign. So here it was greater than. For our second inequality, for the second part, we had to switch the sign and switch the inequality sign and the number to its opposite. So less than -3. And then you're going to solve all parts. So I have to subtract 2 to get 2x is greater than 6, divide by 2, divide by 2, so x is greater than 3. Or, and I'll come over here and solve this one. Oh, and I put an 8, 3, and it was supposed to be an 8. So minus 2, minus 2. So 2x is less than negative 10. Divide by 2, divide by 2. So x is less than negative 5. So x has to be greater than 3, or x has to be less than a negative 5. So to graph this, we have to go to the 3, and we're going to leave the circle open because it does not include 3, and it has to be all numbers greater than. And we're going to go to the negative 5, again open, and it's all numbers less than that. For this next example, I find it easier because I find and inequalities easier. Since this is a less than, I know it's going to be and. So again, let's look at our first simple equation. Inequality. The absolute value of x is less than 3. We ended up writing that as negative 3 is less than x is less than 3. And then we were done because there wasn't anything else with the variable on the inside. Here there will be, but we start the same way. We're going to pull out, just like we pulled out here, 2x plus 2. We're going to sandwich it between two of the less than symbols. The positive is here, just like the positive was here, and then this is its negative. And then we have to solve all three parts. So we're going to subtract 2 to get negative 10 is less than 2x is less than 6. Divide by 2. So negative 5 is less than x is less than 3. So now x is between them. So we're going to go to the negative 5, open circle, and the 3, open circle, but now it was an and it's in between. Alright, and that is it for part 1 of solving absolute value inequalities.